look at a couple infinite geometric series here and see if we can figure out if the series has a sum, if it converges to a finite sum, or if it diverges. And if it does converge to a finite sum, let's go ahead and find that. So two quick examples right here. The first one written in summation notation, the second one not. Looking at this one written in summation notation, I can very quickly see the value of r here, what's being taken to the power, that's where my common ratio is negative 5/4. The absolute value of negative 5/4 would be 5/4, which is in fact greater than or equal to 1. In fact, it's greater than 1. Therefore, this series diverges and does not have a finite sum. So I'm just done. It doesn't converge to a finite sum, so there's nothing I can really do there because of that. Now, looking down here at this series, it's not quite as easy to see the common ratio. It's not written right in front of you, but we talked about how to find the common ratio. Just take a term divided by the term before it. So I have 1/2 divided by 1, which is 1/2. I have 1/4 divided by 1/2, which is 1/2. So the common ratio here is 1/2. The absolute value of 1/2 would be 1/2, which is less than 1. So this series should converge to a finite sum. So let's go ahead and look at a formula for that. In the previous example video, it said this will converge to a finite sum S. So we have a formula to find that finite sum S. That formula is as S equals A sub 1 over 1 minus R. It's not really that complicated of a formula to use. You need to know your first term, and you need to know your common ratio, which I in fact do here. My first term of this is 1. So I have 1 over 1 minus. I just talked about the common ratio. The common ratio was 1/2. So I have 1 over 1 minus 1/2 is 1/2. 1 divided by 1/2 is the same as multiplying by the reciprocal. The reciprocal of 1/2 is 2. 1 times 2 is 2. So this infinite geometric series will converge to a sum of 2. That's a lot like the example I just talked about when I introduced this idea of converging series. If you look, I actually used that series, which converged to 1 as I illustrated. So I've just put an extra 1 in front of it, so that would make it converge to 2. I think that should make sense as well. So here's your formula for finding the sum of an infinite geometric series if you know that that series is going to converge to a finite sum. If it doesn't, you can't do anything.